Hi everyone, welcome to lecture 5. Today's topic is about Apache Spark, second technology for big data applications, and very important technology that I'm gonna, cover it for week 5, or let's say lecture 5, and the rest of the lectures. So we have Spark Introduction. I want to go through that to see what exactly it is. And then we have to compare Spark and Hadoop to find out when we have to use Spark and when we have to use Hadoop. So Spark Engine, we will go through that, and Spark RDD, the main data structure in Spark. And we will learn to how to deploy Spark for programming, coding, and big data, developing big data applications. And we have two platforms for Spark, or let's say PySpark, since we want to use Python in Spark. We can use PySpark keyword for that. And we can use Colab, that's an online platform using by Google. And also Ubuntu desktop, that if you prefer to use the, desktop version for Spark. So I want to cover the last one for tutorial session, guys. So let me have a recap of Hadoop, then we can go ahead with Spark. So I want to start from storage that we learned so far about Hadoop HDFS, that we talked that this is for storage where you can collect your data. You can divide your data, split your data into, several portions, and each portion size is 128 megabyte. And that's a default version, or let's say default size. And if you want to go ahead with like the cloud-based storage, or you want to have the mix of desktop and cloud-based, storage, you can go ahead with Alexio. That's very advanced data storage platform. You can go ahead with that. For resource management, we have learned so far about Yarn, and we saw that how Yarn is gonna to manage resources, for CPU, memory, and how to run jobs, on your cluster. But if you're facing with data centers like huge data, terabyte, petabyte, zettabyte, yottabyte, huge amount of data, you should have data center approach. So if you want to manage the cluster for resource management, you can go ahead with Mesos. This is very strong resource manager that you can trust on for data centers. And if I want to start from to how to process your data, uh, as we discussed, MapReduce, this is exactly, hard disk based technology that it would run your queries, your processes, through a hard disk. Since it's using hard disk, it's gonna be, uh, is shouldn't be very quick respond, to your queries and your processors. So what we can do, we can go ahead with in-memory processing, that they are providing memory, at the, basement of your processing, like Spark, that I want to discuss it, or Ignite. This is another, platform, or let's say another tools or ecosystem by Hadoop, that is gonna be, it's gonna be similar to Spark, but the big difference between Spark and Ignite is Spark data structure, that we call it RDD. It's like immutable, means it's read-only, but Ignite's gonna be make it writable as well, to be able to, manipulate your data, through any in-memory based processing. That I want to discuss Spark, for 3-4 weeks, and you will learn it, in depth. About the streaming processing, all these three, ecosystems or tools, they are all memory based: Kafka, Storm, Flink. So I basically cover this streaming processing for MSc Big Data Technologies, who, student who have uh, module like machine learning and big data. I will cover streaming analysis on that module. So with these tools, you will learn to how to deal with streaming data, like the very simple example is Uber, where you wanna get the car or get the driver, and go somewhere with Uber. In this case, you have to request from Uber that where you are exactly by sending your position, and then Uber is gonna to consider your request by any driver close to you, and so on. Right? This is very simple example that there is no databases, there is nothing, just real-time processing. For real-time processing, we need memory, we need RAM. You have to ignore hard disk because hard disk is not quick enough to respond your queries, at real time. SQL over Hadoop, that we work with Impala. We practice, at scoop session. If you want to input your data by scoop inside HDFS, you can use Impala editor to work with Parquet files, or you can have, complete, data warehouse using Hive inside your HDFS. And another one is Drill. Drill is the advanced version for, relational databases. In this case, you don't need to have warehouse like Hive inside HDFS. You can get access to any relational database from anywhere, and you can, bring those data, directly to your HDFS for only processing. So the big difference between Hive and Drill is Hive should bring data inside HDFS as a data warehouse inside, but Drill is a data warehouse outside. In this case, we don't need to have data warehouse. NoSQL for analyzing, text, any unstructured data. Search engine, Soul is the proper tools if you want to have, searching, indexing, hashing, indexing, and so on in your data. You can use that. Data piping, that we practice Scoop to bring structural data, and Flume is for unstructured data, that if you want to bring them inside your HDFS. And NiFi is another version for importing data. This is for huge amount of let's say very huge amount of data, because these are very advanced tools that you can go ahead with them for facing with unstructured data, for huge size data, even distributed files. And also machine learning libraries. Spark machine learning library is basically on memory. Mahout is based on hard disk, and the difference is just using your resources, hard disk based or memory based. And a scripting Pig. So I can say, guys, Pig is somehow outdated, and because of using Spark, that this is memory based processing that you can trust on, and apply any scripting with Python or with a Scala, even with Java, on your data instead of Pig. Pig, the main issue with Pig is, hard disk based application, and it takes lots of time to run it, over your huge data. So, and then we can go ahead with scheduler, Uzi or Airflow. If you have a huge cluster running, let's say if you want to run more than 100 or more than 1,000 jobs, per second or per hour. Just imagine Yahoo. If they are working with customers, there are, millions of customers. They are running queries, around the world. And if Yahoo is gonna to schedule their job to get those jobs, one by one, to put them in a queue, and then give them proper resources, and buffer them, and then or these buffer can be window-based buffering, or transaction-based buffering, different techniques. We can discuss here with Uzi or with Airflow, and it's gonna to just to schedule jobs. If you are facing with a huge amount of jobs coming from customer on your cluster, you can install and configure your cluster with Uzi. That's gonna to have just scheduling jobs based on your available resources. And security, I mean, for security, I mean, we can declare and we can define and configure authentication and authorization, even confidentiality on your data with security approach like Apache Ranger. That's very strong application, or let's say ecosystem in Hadoop. Even metadata management Apache class, something like if you want to manage your name node, or even any of these, ecosystems, they are having like metadata, because they have to keep tracking of their log files. Something would be something like log files. So where we can manage them in Apache Atlas. And the data format, this is just, it's gonna say you can work with different data format in your, I mean, HDFS or Hadoop. And at the end, zookeeper, right? This is coordinator. This is the, I mean, is a guy, something like guy that would be a police, um, or let's say as a doorman for your, for your cluster, is gonna manage every single component. If you want to add or remove, any components, you can do it through zookeeper. If you want to configure, your cluster based on these, uh, based on these ecosystems, you can use zookeeper. And if you want to manage all this stuff all together, if you want to manage all stuff together in a cluster based, environment, you can trust on Ambari. So Ambari is the platform, or let's say is the system, and it's gonna give you, the full access to your cluster and run your cluster over, data centers, or through lots of workstations. So these are all the stuff you need to know about Hadoop. It means if you want to be expert in big data, you need to understand each ecosystem individually, and you need to know, I mean, when you have to use which, ecosystem. So these are all the stuff about Hadoop, and the important stuff here is, guys, the most of these ecosystems, they are based on MapReduce, right? Since they are based MapReduce, it means they are hard disk based technology or hard disk based tools, and it would take lots of time, to process your request. Even, I mean, if you're working with, big clusters, in this case, MapReduce would be, a point of problem, because we want to speed up the process, in in big data clusters. Let's say I have terabyte data. So since the problem is the size here, so I have to rectify the problem with the size. So we can go ahead with, splitting data, but that's fine for splitting. You can put them inside your storage. But the problem here is how we can process, how we can process this huge data. If you want to trust on hard disk, it would take lots of time. Even if you try that, even for the single or simple application like counting the word count based on unique words, uh, if your file is terabyte, if you want to go ahead with, pig, that's a, I mean, that's a hard disk based, method. It would take like more than 2 hours, to complete your process. So, I mean, it's a lot, we have to, I mean, decrease the time complexity of your applications. So how we can do that? It means we can consider, new technologies like Spark. So two main problems with MapReduce. The one problem, and the huge one and the big one, is, we can't, I mean, describe any problem with MapReduce. I covered it at week 3. I said that imagine I want to write the for loop, simple instruction in, I mean, any coding. So how we can convert the for loop to MapReduce? Imagine I want to write a query, simple SQL query. How can I convert it to MapReduce? So these are all the problems, with MapReduce jobs. And also, disk is basically slower than memory. So disk is gonna to use by Hadoop, and memory is gonna use by Spark. So that's a big difference between Hadoop and Spark. So as I mean, as I said, since Spark is gonna be over memory, so it's gonna be 100 times faster than Hadoop because of only memory, and Spark is more usable as compared to Hadoop, since you can develop your code maximum, or yeah, it would be like maximum 10 times or 20 times less lines of code. Because if you want to go with any MapReduce jobs, you have to develop driver code, you have to have mapper code, reducer code, and partitioner code. We had this discussion, guys, at week 2 and week 3, and we need lots of stuff, to go ahead with map and reduce. So Spark is very, rich in terms of programming languages like Java, Scala, Python. You can use either Java or Scala or Python, and they would be interactive, interfaces. It's much easier to go ahead with, your code. So another approach to compare Spark and Hadoop is about if you have data in HDFS. So if you want to apply simple code, let's say you want to apply even scoop or hive or peak, anything you want to apply on your HDFS file, you have to first read your data from HDFS. If your code is iterating something like for loop, then the first step is done. It's gonna to again to print it out in hard disk, or if there is no printout in hard disk, it's gonna to start reading again from hard disk and go to iteration 2, and it's gonna to be in again to a hard disk, and so on. So guys, accessing to hard disk in different occasions, it takes lots of time. But imagine if you use a Spark and HDFS read. Let's say your data is in HDFS, So you want to apply a simple code like applying for loop, to print out a message. Just very simple application. First iteration is gonna be get your data on, on memory. So, and then once it's done, second iteration gonna be again on memory, and this is completely in memory base, processing, and any step you want to add is gonna be on memory. So you can see at each, iteration, the speed is like about 100 times more than, Hadoop. So very unique technology. We're talking about Spark. If you want to discuss about, memory, as we said that Hadoop, it's not using memory. So Spark is using, memory using RDD. I want to explain what is RDD. So disks usage, Hadoop is disk oriented, but Apache Spark, we can't. It's better to avoid using disk, but in some occasion we can use disk oriented processing. I want to let you know when you can apply it, but basically Spark is running on memory. Processing is running only batch, means you should have your data available and then start working on it. But Apache Spark, you can run real-time processing because it gives you this, opportunity and well enough room to go ahead with real-time applications, because Spark giving you, this environment to work with real-time data. So why it giving you this opportunity? Because that's memory-based technology, and on memory, since the speed of processing is 100 times more than hard disk, so then you can have real-time applications on Spark. So installation, MapReduce, Hadoop MapReduce. For running MapReduce job, you have to work only with Hadoop. So, but Spark is not restricted to Hadoop. You can you can set up configure Spark, and also and then you can read data from anywhere. It's not bounded to Hadoop. But MapReduce, you have to read data from HDFS directly. So, there is a big question that if we say Spark is better than Hadoop, in terms of processing. So why we're using Hadoop? So what is the point of using Hadoop? Since Spark is strong, can read data from anywhere, from HDFS, from your local files, from cloud-based storage. You can read data from anywhere. But Hadoop is restricted. And also, if you want to use Hadoop, you have to trust on MapReduce. That's a hard disk-based technology. So Hadoop is gonna be slower, as compared to Spark. But what is the point that what we have to use Hadoop? Guys, there are two reasons that we have to use Hadoop. So with Hadoop, we can have big data clusters, right? You can develop your clusters, like if you want, you can have methods for your data centers. You can divide your data into HDFS, or you can keep your data in a single file and then apply Spark on it. So with Hadoop, you can set up Ambari, Zookeeper. You can have a proper cluster management with Hadoop. But Spark, there is no, or let's say there is, weak cluster management. With Hadoop, you can store your data, divide your data, and would be available in HDFS at any time. But Spark, there is no storage. So for a Spark, you have to read data, at any time you want to execute your code. So the one big difference between Spark and Hadoop is with Hadoop, you can set up a cluster, and this cluster includes of, Hadoop or Spark ecosystems. Because once you set up your Hadoop, inside the Hadoop cluster, you can add Spark as well, right? And also for Hadoop, for instance, you can set up, authentication, authorization tools. You can set up, search engines. You can set up NoSQL, MySQL. Everything can be set up on Hadoop cluster, and you can have, management approach on it using, Zookeeper or using Uzi, and these are, very strong packages available in Hadoop. But in Spark, we don't have these, these features like, I mean, uh, job management, like having Uzi or uh, Zookeeper and so on. So Hadoop in this case is, stronger than Spark. Guys, Spark is better than Hadoop based on only processing, guys. Only processing is, better than Hadoop. Sorry, guys, I'm very bad in, using mouse for typing. So Spark based on processing is, stronger than Hadoop, and Hadoop would be, degrading your efficiency of, of codes. So the second big problem, or let's say the second big, difference between Hadoop and Spark is, is money. So what does it mean? Guys, imagine you have 300 pounds. So you have to think that how you can develop your Hadoop cluster or how you can develop your Spark engine. Guys, since Hadoop is the hard disk based technology, with 300 pounds, you can buy something like 10 terabyte data. So with 300 pound, right? You can buy something like 100 terabyte hard disk. I think with this price, you can buy something like 64 gigabyte RAM. This is hard disk, right? And this is memory. This is memory. So guys, can you see the big difference between, Hadoop and Spark based on 300 pounds? So with 300 pounds, you can have 100 terabyte, or maybe, I think it would be a bit less than maybe 50 terabyte. I'm not sure about, the current prices, is going to be changed. But I think it would be like by 50 terabyte or 40 terabytes, you can buy hard disk. But with 300 pounds, you can buy 64 gigabytes, something like that. So it's a big difference between 50 terabyte hard disk or 64 gigabytes. If your data is like 10 terabyte data, if you have 10 terabyte data, right, you can easily, import it inside your HDFS because there is 50 terabyte storage. But how you want to process 10 terabyte data, over 64 gigabyte. So it would be something like a failed solution, but it would be successful solution. So if you want to set up or run your 10 terabyte data over 64 gigabyte RAM, it means you have to divide your data into maybe more than 1,000, blocks. But it would be much easier to work with, Hadoop in this case. If you want to use 10 terabyte data over memory, so in this case, you have to increase your memory size. For instance, you can go ahead and buy, let's say, maybe let's say, I don't know, if you even go with 512 gigabyte RAM, it would be more than 1000 GBP, or let's say pound, So I mean, as you can see, guys, based on the money, you wanna spend. It's a big difference between Hadoop and Spark. So if you want, I mean, big conclusion, if you want to use a Spark on a huge amount of data, right, you have to spend money. You have to buy more memory. But if you want to work with, if you want to spend less, like you have to go with Hadoop. So Hadoop is much, much cheaper than, Spark. So that's a big difference. So the two big difference, I mean, based on spending money on memory on hard disk, and the second big difference, guys, is with Hadoop you can set up a cluster of ecosystems, and then even you can add Spark as a part of this ecosystem inside Hadoop, and then you can manage your cluster easily. Guys, if you get this expertise to set up Hadoop clusters and be able to manage those ecosystems, I mean, it would be huge money on it. So even in UK market. So Spark cluster. This is, guys, similar to job tracker and task tracker in Hadoop. But let's see how a Spark does work. So Spark context, or we can say SC, is responsible for interaction between user and your system. So Spark context is a driver program. So then you have a cluster manager. The cluster manager can be here, guys. A cluster manager is responsible for resource allocation. So it means how to allocate CPU and memory. So for cluster management, there are different options in Spark. You can use Spark engine itself for cluster management. You can use Yarn for cluster management, or you can use, Kubernetes for cluster management, or you can use any, cluster manager, available, in the market. You can use it for your, managing your Spark. And there are, worker nodes. Worker nodes, they are like data nodes. These are like data nodes in Hadoop, but here we call them worker node. So guys, worker nodes, they are is better to assume that each worker node is exactly one CPU, core. If your CPU is dual core, this is your first core, right, for the first worker node, and this is your second core for your second worker. So it means that, guys, the dividing data in Spark is completely different by dividing data in Hadoop. In Hadoop, we can divide your data in many, blocks as you wish. But in Spark, it's better to divide your data based on number of CPU. So I want to explain in next slides that how does it help us, to have it, something like, this approach. So let's say I have dual core, in my machine. So one core, the first core is worker node, and second core is also the second worker node. So executor, this is your task. Let's say I'm gonna to run 4 tasks, over, the data splitting in 2 worker. So in this case, you can run several tasks. with the executor and several tasks with the executor. So guys, since CPU is gonna to deal with memory, because here also we have memory. Let's say this is memory. In this case, worker node is gonna to deal with memory, to execute these tasks, and this worker node is gonna to deal with memory to execute these tasks. And there is cache, because cache can be used from CPU cache and also memory cache. So cache is gonna be speed up your processing. So once the job is done, they all sending back the result to cluster manager, and cluster manager gonna to send back your result to Spark context, and the Spark context is gonna to send back data to user, right? This is, I mean, the stuff and story about Spark much easier than, and I mean, advanced, in the advanced level for managing your cluster or your resources. And who's gonna manage whole stuff? There is something we call it Spark configuration. SparkConf is gonna to manage all this stuff together. If you want to get more information, guys, you can go ahead with these, two links available, this link and this link. So let me make sure everything is going well. Spark ecosystem, guys. If you want to have a Spark, like Hadoop in ecosystem, hierarchical view. So in Spark also we have a storage. In storage, can you see we can use HDFS, you can use Amazon S3, you can use a relational database, you can use semi-structured or unstructured data as a storage. Management, guys, you can use Hadoop Yarn, you can use Apache Spark Engine itself or Mesos for data center approaches. Engine, guys, engine means Spark is gonna to handle, all these, 4 layers all together. And library, Spark SQL, we want to consider it, guys, in this module, Big Data Analytics. Spark Streaming, very advanced, very interesting. I'm not going to cover it for Big Data Analytics. I will cover it for, MSc Big Data students, so I have to cross it. Spark Machine Learning Library, I want to touch a bit, of this library for this. Let me to take it twice, means I will have to cover it, and for this one I will touch it, but for MSc Big Data student I will cover it in depth. And Spark Graph, this is very advanced topic that would be like your self-study, guys, if you want to get expertise on Spark on graph analysis, like analyzing like Twitters, Facebooks, or any social networks or social media that you can trust on Spark GraphX. So this is very advanced. If you wish, you can consider it as your final year project, as your dissertation, or if you wish to go ahead with PhD, your further study, you can trust on GraphX and improve your increase your knowledge. And programming side of view, we can use a Scala. This is, dedicated programming language for Spark, Java, Python, R. But R is not user-friendly in this case. Guys, the most application available in the market, they are based on Python and Scala. So in this case, guys, for the course, we are gonna to work with Python, because with Python you can work it, Python can work anywhere. You can, easily develop any application with Python, even it's not for big data. But the Scala is basically only for, Spark, for big data applications. So we want to go ahead with Python, even there are lots of, examples, tutorials, and hands-on experiences or hands-on practices using Python. So in this case also we want to use Python in for the Spark. So let's start Spark Engine. RDD, Resilient Distributed Dataset. Guys, RDD is a fundamental data structure in Spark. It means if you want to load your data inside Spark, you have to give it to RDD. RDD is responsible for getting your data. Since this is immutable, means this is read-only data structure, you only can get data, and apply your processing on it. You can't change any lines or any words of data because that's read-only data. So, and this is fault tolerant and read-only, partition collection of record. So RDD is using graph-based data structure. We call it directed cyclic graph. So it's gonna to speed up your, speed up the process of data using graph analysis, because usually graph data structures, they are, the time complexity of graphs, on the in worst case would be, uh, but usually they are, big O log n. If you remember data structure, these are O log n, but in the worst case would be, n power 2. This is a worst case, but usually they are, the time complexity is log n. So much better than, tree or array, linked list, or, any other type of data structure. That's the reason, Spark is much faster, is, as compared to Hadoop. So there are two ways to read data, for RDD. We can parallelize the input, with giving like some, some artificial data, or you can read it, a data set directly from anywhere, HDFS, HBase, text, Amazon, even, CSV file, any type of data, you can read it directly into, you know, uh, Spark using RDD. So RDD, that's a masterpiece of, Spark. So very important. Caching in RDD. Guys, since RDD is gonna to set up in memory, if if a part of your data in RDD is gonna to use, in different occasion, or let's say you have an iteration of a job, and if you want to keep tracking or keep working on a portion of data, over your iterations, you can keep a part of RDD, in cache. So if you keep it in cache, in this case, you can speed up, your processing, and that's important, configuration. Persistence in RDD. Guys, as I said the example about, spending money on buying memory or hard disk, uh, if let's say if you have, let's say you have 64 gigabyte memory, but you have like 1 terabyte data, but you want to trust on and you want to work on, Spark, because that's, faster than faster than Hadoop. So what we can do, guys, since RDD is gonna be divided into like here 3 portions, in this case, you can say partition 1, you can go ahead with memory as usual. Partition 2, you can go ahead with, memory as usual. But since we have no well enough space in memory, I can put partition 3 of data on disk. So in this case, you can use, the combination of disk and memory together. This is, guys, a very unique feature in Spark. So in this case, you can, you can degrade your performance of the code, or let's say of the system in Spark, but at the same time, you can use memory and disk together. But Hadoop is basically, trust only on disk. So in this case, you can have, the combination of, memory and hard disk. So guys, programming, very important part. Spark operation, guys, we have two kind of operations. We call it transformation and actions. So for transformation, it shapes your data set. It means if you want to apply any mapping, filtering, joining, you can apply transformation. This is, guys, similar to mapper phase. This is exactly the mapper phase in Hadoop. And action is exactly aggregation part. This is exactly reducer part. Reducer part. Right? So action is gonna to collect, or let's say aggregate your result, like count, collect, and save. Guys, if you want to do any coding in Spark using RDD, so as a data structure, we can, we can use transformation and action, guys. Very important. We will practice it, guys, in detail. I want to start a quick, let's say something like quick start, for today. And for week, let's say 8 and 9, we can go ahead with these two operations, guys, in detail. So guys, if you want to know that what type of operations are available in transformation phase, you can go ahead with this link. But the most used one are map. In this case, we can return a new RDD by any calculation or operation on it. You can have a filter on your data. If you want to have key value approach, you can use reduce by key, group by key, or union for combining, aggregating several RDDs together. Actions, guys, it's much easier because in action you can go ahead just with aggregating your result, print out your result, collecting your result, and so on. As you can see, count is gonna to count the number of elements in RDD, collect gonna to print out your data in RDD, reduce is gonna to apply the function on your data to degrade, or let's say to decrease the size of RDD. Take means if you want to print out a specific number of elements in RDD, or for each operation. This is another interesting operation with action. You can apply a specific operation on RDD on a loop base approach, or first is going to print out the first data element in RDD. So guys, we will practice this stuff, no worries about that. So guys, it would be example about transformation and action. Guys, we have two type of transformations. Few of them, let's say here, transformation is gonna be with map or distinct or group by. Guys, if you have your data and then you split out your data in 3 nodes, right? And each 3 nodes, guys, these 3 nodes can be 3 memory, can be 3 workstation, and so on. And each node is going to keep partition of your data. If you want to apply group by, distinct, or map, that we will practice, guys, this stuff, you would see you can have exactly the same partition, same node, same partition, same node, same partition, same node, same partition, same node, right? It means you can see you have exactly a copy of your first step, a copy of the first step at second step, but with new calculation, new operation on your original data. In this case, if you think partition 1 is gonna be used frequently within your calculation, you can put it in cache. You can keep it in cache, or if you see your partition 3 is you have no well enough space in your node 2, you can put it in hard disk with persistence, and so on. Can you see that, guys? You can work out with nodes and partitions easily. But for some transformations operations like filter and join, as you can see, you can decrease the size of your partitions. At the first step, I have 4 partitions, and the rest I have 2 partitions. So how many partitions for RDD, guys? That's important part. Let's say I have a CPU with let's say I have CPU with 3 cores, right? These are my CPU. If you divide your data, this is data, and if you divide your data to 4 portions, how does it work? So once you declare it, Spark context or SC is gonna to send first portion to first CPU or first core, second part to second core, and third one to third core. And we have one portion free, right? Is here because we have no space on on your CPU. And here is memory, and they are gonna to complete tasks. They are in in interaction with memory to complete your task over your data. Guys, this is here, right? And when we have to use it, the answer is if you get your one of your CPU free of, operations, then you can use, the last portion. Guys, these are running in parallel because we divided data in 4 portions. We send the first portion to first core, second portion to second core, third portion to third core, and they are running in parallel using memory, right? Since, in the next step, let's say CPU are free, because since they are working in parallel, they would be free, simultaneously, at the same time. Then one portion is free here. So one portion is gonna be here, and these are be idle. So guys, these are be idle, idle one, and this is another idle. So guys, as you can see, 2 cores of CPU are idle because of one CPU was running over, these processing. Guys, can you see that you are, misusing, or there is something like malfunctioning on CPU? So since, guys, this is, bad configuration. This is the worst configuration for Spark. So it's better to keep, the number of partitions based on the number of cores, you have it in your CPU is much better. Guys, as you can see, there is no any default size of data. In Hadoop, we had default size like 128 megabyte, but here the number of portion is important, regardless of the size. Here the size is not important. Let's say if you have 400 gigabyte data, if you divide it in 4 partitions, it would be, each partition would be, uh, something like 100 gigabyte, right? And then for 100 gigabyte would be 400 gigabytes. So in this case, your blocks would be 100 gigabytes for each, CPU to work on your 100 gigabytes data simultaneously in, as a parallel processing. So this is what exactly I wanted to cover for Spark. So guys, from this page, we have to start having some simple coding on Spark. I want to explain it, and then we have to practice it for tutorial. So guys, if you want to start with the Spark, first of all, we have to create RDD, because RDD is a data structure keeping your data, and then we can use transformation and action on RDD, right? Three steps we have to complete, guys. So one important stuff about configuration of Spark. Before, guys, going through your, Spark coding, you need to have, a Spark configuration. So Spark configuration is a method that can, to set up, or let's say to configure your Spark application. There are two main, attributes in Spark configuration. We call it set app name. You can, set up, or let's say, you can give a name for your application, and set master, guys. Very important. This is your cluster manager, right? Let's see what is that cluster manager. We have 3 type of cluster manager that they are frequently used for, this step. Let's see what are these, guys. If you set it up by local, is gonna to run Spark locally with one worker. So it means if you have CPU like 4 cores, with 4 cores, in this case you are using just only 1 core, so not really interesting. Local K, guys, K here is the number of worker threads, means the number of cores. If you CPU is like is like 4 cores, and if you put like here 5, it would be the problem that I explained in the recent pages. I explained in that slide that if you put the number of blocks of data, more than the number of cores, CPU cores, that would be, degrading the performance of your application, is gonna to, I mean, just increase time complexity. So, I can suggest to ignore it. But if you know you have like 8 cores, and if you are sure that you can use it maximum 8 here, and then you can use it. Otherwise, it's better to ignore it. K and F, in this case, you can trust on your, I mean the maximum failure. In this case, guys, if you have like let's say I have 8 cores, I'm putting 8 here, and maximum failure is 4. What is 4 here? 4 means if you run the job, even by Python or Scala or any programming language, if you run it with, I mean, 4 times, and if you get error for any reason, a system error, guys, not your programming error, even only, I mean, system error. If you get any system error, it means your CPU or maybe your memory, they are not responding at this time for any reason. So in this case, you can trust on replications. So you can use this one or local asterisk. This is the most used one, guys. Because in this case, if you set it up by local asterisk, it means please run Spark locally, with as many worker thread as. It means if your machine is with 8 cores, it would set it up to 8. If it's like 10 cores, it's going to set it up to 10 and so on, right? But guys, if your Spark is running in another machine in the same network, you can use this one. Or if you're running with separate ports, if you want also using methods on your, data management, even if you want to use yarn, guys, these are, configurations that you have to do that. Or if you are using Kubernetes, you can use, this configuration. But basically, I mean, this one is the most frequently used one, guys. So, but if your cluster is a huge cluster, you want to use the other, cluster managers. You can trust on Mesos or Yarn or even, the other combination. So, guys, this is configuration for Spark in Colab, and I want to explain in tutorial session that what exactly these, configuration and codes are saying us and how we can, work with them. Just I put it here, right? Just for your guys, for your reference to know what exactly we need to do. If I want to go ahead with that, shortly, we have to firstly, install Spark in your Colab. Colab is the, I mean, online platform developed by Google, and we can use it. But if you want to use it, make sure to firstly install and set up Spark. In this case, we are setting up Spark version 3, the latest version. And then in this case, we have to unzip it. And then we have to import, OS here is operating system. Since I want to, to read and write dependent files in operating system in Colab, like these environments, I have to import it and then set them up that says, okay, I'm going to use this Java 8 and I want to use this Spark 3 as a Spark Home and Java Home. And then I have to load the Spark engine. So pip is gonna to, I mean, install and download and install this fine Spark package. And then you can import it and start your Spark. And then you have to link your, application with Spark. As I said, guys, you need Spark context. This is in, interaction with end user, and SparkConf or Spark configuration is going to configure your Spark. So how we can initiate Spark? You have to say SparkConf, set application name. Here I made as a test, and set master. Can you guys see that? Local asterisk. It means create, I want to use the maximum number of cores, CPU cores available in the machines running this application. At the end, I'm declaring the variable, I'm naming SC. SC is abbreviation of Spark context. So in this case, I want to say Spark context. Configuration of that is conf. What is this conf? Is exactly this conf. So once you run all these together, SC is in the point of, connection between end user and application. And guys, you would have only the 3 last steps for Spark if you are using Spark in Ubuntu machine or any desktop version. So for Colab, you only need to have this, this step. This is the extra step you need it for Colab, and these are 3 steps for Ubuntu one that we are using, or I mean, any desktop version you prefer to use. So guys, let's start few examples, and then we have to practice these examples in, I mean, in tutorial session. Step one, so data loading. So in this case, I want to create RDD. I'm gonna to use parallelize. So let's say I have this data, simple data, right? Guys, we are using Python. In this case, I want to say sc. Guys, we configured sc in previous slide, right? Sc dot parallelize data and then for. What is this for? It means I want to divide data into 4 portions. So guys, in this case, for this case, guys, this is, I mean, doesn't make sense to for these very simple data to split it in 4 partitions. But this is just for only example, guys, to understand the topic. So if you want to divide this data into 4 portions, Spark is going to put, for instance, 1 and 2 in first portion, maybe 4 and 7 second portion, 11 and 15 in the third portion, and 20 at the, I mean, last portion. Guys, I mean, we don't know that how Spark is going to put them all, you know, in 4 portions. Maybe it's going to put 1, 2, 4 in first portion, 7 individually in second portion, and so on. This is just, you know, example to see. So if you type RDD, it's gonna just give you, you know, the message, right? There is no output. How can I print out these, you know, data from, I mean, from RDD? You have to use action operation, RDD dot collect, right? This is action, right? Action means collect means print out data completely. So if you want to use PySpark Shell, guys, PySpark means Python plus Spark. So PySpark Shell, if you're using, desktop machine, you can go ahead with localhost colon 4040, and then here you can get track of, you know, your, operations, your processor, processing with Spark. Since job, for instance, in jobs you can see, for instance, this says 28th of October at, this is a time 6:12 minutes, and this is the second, right? There is nothing, but here at 18:13, right, at, you know, second, maybe this is second 7. I mean, we execute, you know, the code, and you can get, you know, well enough information about the job you made it. So, and then another way to work with RDD is, read, you know, file directly from your local machine or from anywhere, right? So in this case, you have to say sc.text file. So I'm gonna to get this file, I'm gonna to divide it into 3 portions. Guys, RDD, we say this is lazy evaluation. What does it mean? It means, guys, once you want to run this, you know, this block, once you run it, there is no any execution on the code. So when you have execution, when you have action, operation, once you run any action operation or transformation operation, then you would have execution on it. So, if you run this command, there is nothing to happen. Your data is not going to be divided in 3 portions. When you start writing, you know, transformation and action, then it's gonna be executed. So transformation, guys, we have 4 main, you know, operations: map, filter, distinct, flat map. So map is gonna to return a new distributed data. Filter is gonna to return a new data set by selecting, you know, it means there is filter. Distinct is gonna to remove duplicates, and flat map is exactly map, but map is gonna to return values based on each mapper or based on each block, but flat map is gonna to return your data in a sequence order. So we can use flat map. It's better to use flat map for key value programming like MapReduce programming. Let's have some example, guys. This is the RDD, we made it 1, 2, 4 and something like that. So then I'll have to start, guys, writing Python code. Let's see how we can do that. Guys, I want to get these values, right, one by one. and do this operation. You know, I want to say firstly make it plus with 2 and then multiply by 4. It means 1 plus 2 is 3, 3 multiplied by 4 is 12. 2 plus 2 is 4, 4 multiplied by 4 is 16. So I want to have this simple operation on this data. How can I do that? Guys, you have to use that map. This is a function. And then inside the map function, guys, you have to have, you know, Python code. So how can I do that? Guys, I mean, if I want to develop a Python function, I have to say def, and then I have to say a name for function like function1, f1, and then input, colon, and then you have to write your Python, right? And then in this case, you can say rdd.map, and inside, I mean, parentheses, you can say f1. It means you have to call function f1 and apply this function, I mean, this f1 function over your data. Guys, but there is simpler way. You can use lambda. Guys, lambda is anonymous functioning in Python. It means, let me put it x here because I have to have x here, and here would be x equal something x plus 2, you know, and multiply by 4. It would be something like that, right? So instead of having this, you know, difficulty of writing Python code in some lines, you know, maybe three or four lines of code, you need that. You can easily put them on a single line, you know, in your map function. How we can do that? Here, guys, you can say lambda. Lambda means there is anonymous functioning. It means you don't need to type. You can ignore typing def and even typing f1. And you can say only input. So input is x, and what is output? You can say input x colon and then output. Output is x plus 2 multiply 4. So I want to run it over data. So in this case, I have to say rdd, this data means this data, dot map. Dot map means run this Python code, you know, over this data. So once you run this line, and then you can use collect because we want to get output, right? Collect means print out, right? Print out output. So RDD1, guys, I want to send the output of this calculation into a new RDD. So RDD1 is rdd.map, something like that. RDD1.collect, guys, you can see output 12, 16, 24, and so on. Guys, let's execute the same function with filter. Guys, if you run with the same function with filter and use collect, as you can see, guys, you would get exactly the same values here. Guys, because filter is just for filtering, for selecting, for decreasing the size of the data. But if you want to apply, the function on your data, to execute or get output exactly the same number of words or same number of, or let's say the same size, you can use map. But when we have to use filter, the answer is having something like if, then else, or switch, means you should have something like selection, right? If you have selection, it means if you want to check your data, and then you can use filter. What does it mean? It says that apply this function. This function says get input as x. Guys, you can change it to y, z, anything. Get input, there is one input. We name it x. What is output? Output is if x as a dividend divided by this divisor number 3. The remainder, if it's 0, then put it in RDD3. So if you run this, this query, or let's say this command, over this, data, which value is dividing by 3, the remainder is 0. So 1, no, 2, no, 4, no, 7, no, 11, no, 15, guys. 15 divided by 3, the remainder is 0, right? And then once you say rdd3.collect, can you see, guys? It is 15. Let's apply the same function with map, guys. So what we said that, guys, map is gonna to exactly copy, exactly the same number of values exactly in output. Since this function is gonna to select, some values out of these, whole values. In this case, if you use map, it gives you something like that. It would be, bad output. We don't need that. If you run map, it's gonna check. First, one by one. 1 divided by 3, the remainder is 0, no, is print out false. 2, remainder by 3 divided by 3, and the remainder is 0, no, is printing out false. And so on to, reaching to 15. 15, the remainder of 15 divided by 3 is 0, yes, is print out true. So guys, very important to use map and filter in a proper way. When you need them, you have to use them properly. So, and this thing, guys, this thing is gonna to remove duplicates. Let's use parallelize to declare new set of data, sc.parallelize 42264 and so on. Guys, since here I didn't mention the number of partitions, Spark is gonna to use it in one single partition, right? It means there is no division. It's gonna to use one single portion. So one single portion is gonna to send to RDD5, and RDD5.distinct. As you can see, guys, is gonna to remove duplicates. RDD5.distinct, if you type it, you would see something like the system message. But if you want to see exactly the values, you can use action method like collect, right? Collect, it would be gonna to remove duplicates and put them here, in your output. So, if you want to move on, let's have another example. sc.parallelize 1, 2, 3, 4. Guys, since there is no number of partitions, it means it would be only one partition. So rdd6.map. It means lambda anonymous function. X is an input. It means get input, like 1 is input, then 2 is input, then 3 is input, then 4 is input. And then apply this calculation. First you get 1, it would be 138, exactly 138. Get number 2, 249, 249. Gets 3, it would be 3, 5, 10. And if you, run this code, or let's say this, action, it would be 4, 6, 11. Let's say, guys, I want to use exactly the same function, but with flat map. Here I used map. Here I want to use flat map, exactly the same, action. Can you see, guys, the difference? The difference is flat map is gonna to put all output in a single sequence of values. So the difference is only, the way of printing out. This is gonna to print out, each calculation based on each values. As I said, guys, here I have 4 values. If you use map, it's gonna to exactly create 4 output. But if you use flat map, it's gonna to put all, all output together, something like that. This one, flat map, guys, is suitable for map and reduce programming, where you have key and values. This is an action, reduce, take, collect, take order. Let's practice these things. So, RDD7 collect. Guys, you can easily type rdd7.collect, or you can use it print and then rdd7.collect. There is no difference. So it would be rdd7 and it would be rdd8, and this is 7 and this is 8. Guys, if you want to apply a specific calculation on RDD8, for instance, I want to get each pair of values, right? Pair of values, and then multiply by each other. So in this case, guys, this is exactly reduce. So RDD8.reduce, this is a function. It gets 2 input, right? And multiply it together. It means in this case, 1 multiplied 3 is 3. 8 multiplied by 2 is 16. 4 multiplied by 9 is 36. And then 3 multiplied 5 is 15, right? And so on. And then again, you have to multiply these two together and would be one value, these two together one value, these together one value, and then you have to do this one to finally get, one output. So if you say RDD8 dot collect is gonna to print out all values, but if you want to just print out, 4 values, you can easily use take RDD8 dot take 4. It's gonna to use first 4 values. But if you say take order 4, it's gonna to put them, in ascending order. I mean, from smallest value to the largest value, and then take out first 4 values. And at the end, we have action for key value RDDs. Guys, let's, parallelize the example. I wanted to declare these values. These are in a pair. Can you see that? These are in pair. So since they are in pair, 1 is key to its value, 4 is key, 5 is value, right? 1 is key, 7 is value. So guys, again, there is no number of partitions. It means it's gonna be only one partition. If you say rdd.collect is gonna to print out together, I want to have, the approach of key value. So in this case, I can use reduce by key, because when we have to use reduce, guys, if you want to have aggregation, right? So here the aggregation is, doing, this addition between A and B. So it means there is a function getting to input, and please do, this addition, A plus B. So how does it work? Since this is reduced by key, Spark is gonna to find the similar keys. There is key 1, key 1. So 2 plus 7 is 9, right? Is here. We have 1 4 here, 1 4 here, 1 4 here. So 5 plus 2 is 9. Sorry, 5 plus 2 is 7. 7 plus 6 is 7. 7 plus 9 is 16. And then we have one key for 3. Is exactly going to be print out here. Let's have another parallelize. I'll have keys as, numbers. I have values as, string or text here. And then I want to say sort by key. It's going to keep, keys at the first. 1 is the first key, 1, and then 1. So in this case, A, in the alphabetical order is, firstly, and then D is after A, and then 2, and then 4, right? This is, action practice. So guys, I went through Spark, very important technology that we have learned that how we can deal with Spark when we have to use Hadoop, when we have to use a Spark. So we learned that how we can work with Spark in transformation and action phases. And these are all practices. Guys, I want to convert it to tutorial session, and you need to work with them for the tutorial session. You need to learn them, guys, in depth. We need them, and basically for your learning and also for coursework as well. So for today's tutorial, we want to start with Python. If you have no idea of Python, please guys, you have to you have to learn it with your own self-study in your spare time. Is very important. Otherwise you can't complete coursework for Spark, for this big data analytics module. So let's finish the session now, and then I want to record another video for tutorial, guys. Have a good day. I hope you enjoyed this presentation, and see you for next lecture, guys.